Alright, let's talk about leading edge devices. Since we are starting from the aft overhead and we're gonna be moving through all the sub panels, the first panel in our view is leading edge devices, which you can see has the indication of 4 slats, each slats on the wing, 1, 2, 3, 4 on the left wing, and 5, 6, 7, 8 slats on the right wing, and then 2 on each wing Kruger flaps. Now don't confuse those with regular flaps. These are located in the front of the wing. So if you look from the front of the aircraft, I just showed you how the Kruger flaps extend. These are 2 panels in between the engine and fuselage on each side. Those are called Kruger flaps, even though they're in leading edge of the wing. Now, the rest of the panels, 4 on each wing, it's called slats. So leading edge devices, indicator, there are 2 indications where you can see on aircraft. Here you can just press the test and test the lamps. This is basically just tests the lamps on if they work or not. It does not show the current. They don't extend at that time when you press test. It's just the light bulbs. And there is another indication. It's right below the flap indicator. Right here, you have a leading edge flaps transit and leading edge flaps extended. Now, leading edge devices, leading edge slats. These are the 4 retractable slats on the leading edge of each wing, and they are there to improve the lift capability during several phases of flight, mainly on takeoff and landing, but also when approaching the stall region of the wings, basically. So the leading edge slats are at retracted position when the flap lever is at 0 detent, at the first extend position when the flap lever is in 1, 2 or 5 detent, and in the second full extend position when flap lever is selected beyond 5 position. We're not talking about the option of short field package. This is just a regular 737-800. Right, so 4 panels on each wing, in front of the wing, leading edge of the wing. So 1, 2, 3, and 4. And the same on the right wing. These called slats. Leading edge devices slats. Now, in between the engine and the fuselage, there are 2 panels each, 1 and 2. These are Kruger flaps. And all of their indications are these 2 small lamps, leading edge flaps transit and leading edge flaps extended. Don't confuse with the regular flap indication. It has nothing to do with that. And they're also indicated at this device, this panel, sub panel, all right? Normally, leading edge devices are extended and retracted by system B hydraulics, all right? So the aircraft is split into left side and right side, basically, on most of the things, right? So also it's called A side and B side, or side number 1 and side number 2. So some of the Indications show as 1 and 2, so 1 is left, 2 is right, like here for example. And some of them are as A and B, such as hydraulic side, etc. Alright, so you have the test button here to test the lamps of the leading edge devices indication. Just the lamps, it does not actually move anything, you just press the test. And you can see it's split into the slats, 4 in each wing, so this would be the left wing, even though it's kind of, it's if you would have a look from below the wing. All right, so front 1 2 3 4 slats, they go from left to right, and 5 6 7 8 on the right wing, leading edge devices slats. And then number 1 panel and 2 for left wing leading edge Kruger flaps, and 3 and 4 on the right wing. Those are in between the engine and the fuselage. Alright, now the leading edge devices extend via extend lines and retract via retract lines, but this is more specific technical questions. We might get to that later on. So if a leading edge flap or slat is not in the correct position, one of these indications over here will show on a leading edge device annunciator panel. Next things, the transit amber light come on. Incorrect, the transit amber light is right here. So transit lines will come on, or the transit leading edge flaps transit light will illuminate, such as this. As well, so incorrect, extended or full extended green light comes on. So for example, if something would be incorrect, we would have one of these lights would be in either on transit side or in full extended side and just not correspond with the other ones. Or the indication would be not shown at all. Now, another thing, when approaching the stall, the SMYD computer activates the auto slat control valve, extending the leading edge slats to full extent. But this is more onto like abnormal things. We'll get to that in different chapters. Alright, so about timing a little bit. In normal conditions, retract to extend for the slats, retract to extend takes about 8 seconds. And extend to full extend about 3 seconds. Full extend to extend is about 5 seconds. And extend to retract is around 8 seconds, 7.8 seconds. Now on the alternate side and standby system, extend to full extend takes 58 seconds, so rather long. So let's see how they work a little bit. Alright, so as soon as the trailing edge devices such as flaps will start moving in normal positions such as 1, 2, or 5, the leading edge devices will go in transit and go to, after the transit, they go to extended mode. So they're full extended and just extended. So they go into extended, just like the middle, right? So let's throw flap into 1. It's gonna be a little slower. Watch this. Now, first you'll see these slats will start to lit up with yellow amber lights. You see they lit up with transit, and also the transit light will show up here below the flaps indicator. Now you can see the Kruger devices, the Kruger flaps are fully extended already. So they go fast, but it took a little time until slats are to get to the middle position, which is extended. All right, so now we can move to flaps 5. See, nothing changes here except the actual flaps will start moving, and they were moving, but with the leading edge devices with slats, nothing changes. And then there are differences about the Boeing 737-600, 700, and 800 and 900. So we are talking about 800 here. So the LEDs remain at low drag position at flaps 15. And then let's move flap 15. You see they're in transit, and they move to full extended position. So every time they're moved from extended to full extended, or from extended to off to retracted, you'll see these transit lights. Alright, so when leading edge devices are in full extend mode, the maximum speed is 230 knots. This is the maximum permitted speed. So they will be moving to full extend mode when the flaps are past 5. So as long as you're at 5, as long as you're past 5, they will move to full extended mode. Now we switch back to 5. They're in transit and they move back to normal extended position, not full extended. So the 230 knots, this is for full extended leading edge devices. This is the limit. There are a few other rules about the abnormal operations, which we will not go a lot through here. I'll just mention that if only one of the leading edge transit light is on, do not exceed 300 knots or max 65, whichever is lowest. All right. And let's set them back to 0. And you'll see at some point they'll switch back to yellow. The Kruger flaps will retract, and leading edge slats will just go to the off retracted position. See transit. See the transit light here. And then they move to retract. So no more illuminations. We're not going to talk about normal operations here. Normally it's first flight of the day. You can test these leading edge devices, just indications. So few QRH items, quick reference handbook items that are tied to this is the first one is, let's say, LEDs, leading edge devices fail to retract If any leading edge devices transit lights are illuminated, plan 15-degree flaps landing and land at nearest suitable airport. And the other one, which is the leading edge flap, the leading edge flap transit lights is on. If only one leading edge transit light is on, do not exceed 300 knots, or Mach 0.65, whichever is lowest. And if more than one leading edge transit light is illuminated, do not exceed 230 knots. Now later on the test, after the chapter, I want you to remember a few questions about the system we just mentioned. Alright, so this leading edge flaps transit light right here, except when you press test, you see it lights up in amber, except this. When does it come on? So the right answer, so any leading edge device is in transit or not in programmed position with respect to trailing edge flaps. All right, so the correct answer would be the leading edge flaps transit light will come on if any leading edge device is in transit or not in a programmed position with respect to trailing edge flaps. And the other question is, the leading edge devices are normally powered by what hydraulic system? And the answer is hydraulic system Bravo, B.